0. Okay. Hi.
Hello. Where am I? Where are we? What is going on? Is this live?
Yes.
This
Yes, it is.
new system is very complicated.
It's only complicated because my computer here in Illinois is the one set up for production, and Beth, who is in California, is doing the production.
Yeah.
So, yeah. Oh, there's an echo. Why do I have an echo? Because I added my audio twice. Hold on. I was very determined not to be muted. Okay, now you should have my audio only once. Sorry about that, everyone.
I don't have an echo from you on this.
No, because you're hearing me through Rendezvous. You're not hearing the fully mixed audio.
Okay. All right. Okay. Well, then hopefully at this point now the echo is removed. Everything is fine. How are you doing?
I've just been informed that since I echo, I'm not a duck. And so I guess that's how I'm doing. I'm not a duck. That seems like winning on some Fridays.
So fine, I guess so. The trials and tribulations of living in the middle of a West Coast Pacific Northwest rainforest during wintertime continues up here.
Oh, no.
In an attempt to dry out the build site so that we can compact the sand down so that we can pour the pad, the builders built this giant tarp structure to above the building.
Yeah.
And last night, and so far it's been fine. It's mostly been rain, and the rain has collected in these giant, like, I don't know, kind of alien water-filled sacks. Is it sort of pulling down the tarp, and it's just about to shred the tarp. And I've noticed at the last minute, and I'm able to drain these things and get the water out, and then it can sort of shed off the water again.
Oh.
But last night we had like a windstorm come through, and it was exactly in the wrong direction and exactly too fast, and I could hear the wind dismantling this structure last night. And around like maybe 11 o'clock at night, I just heard like wood shredding, shattering.
Oh, God.
And went out, and yeah, the wind had just torn the tarp off and pulled a lot of the wood down. And so they're rebuilding it today, and then it rained, and so now like it's all kind of wet in there again, and that's what you don't want, because it's got to be dry so that the sand can be compacted down, so it's a good place to lay your pad for your building.
Yeah.
So yeah, it's I'm really
God.
looking forward to a time when I can appreciate and enjoy the dramatic West Coast weather as opposed to fearing it, because that's what I do right now, is just like, oh no, it's going to be cold. Like, what if the propane runs out in the middle of the night? Oh no, it's pouring rain. What if that's going to blow out one of the berms that we're building, or some of the, it's going to cause some of the soil we've moved around to turn into a mudslide. So yeah, no, it's been trials and tribulations.
I know you're currently living in a temporary structure. Is it one that is closer to shipping container or plywood container?
No, it's a trailer. The one I'm living in is a trailer, like a 29-foot travel trailer. So the kind of thing you would go camping in.
Okay, so the wind can carry it away, but it's
no, the wind can't carry this away, but the wind can definitely buffet it around a bit. But no, the mice are not gone. Arjun is saying at least the mice are gone. No, the mice are still around. We pull. I mean, I haven't pulled 10 mice in 2 days the way I did half a week ago, but I pulled a mouse out yesterday, and I think one out the day before. So we get about a mouse a day.
So I've been thinking on your mouse issue, because I know that you can't deal with a cat in the situation that you're in, because you don't want to destroy the indigenous bird population.
That's right. Yeah.
You need a dachshund. Dachshunds are mousers.
Oh yeah, that's awesome.
And they love to hunt, and will kill things with verve. And so I've been at barns where instead of having a barn cat, they had a barn dachshund. So you need a barn dachshund.
That's awesome. I can imagine a dachshund on the hunt across our landscape chasing mice down. That would be the best. I love it.
It, they're fabulous when they run with their little tiny legs.
Yeah.
They have T-Rex legs.
So we're going to do an episode on this, but finally, Decadal Survey 2020, only a year and a half-ish beyond 2020,
Yep.
came out. And have you read it yet? Or
Not
have you
yet.
even like it's like 600 pages. So,
I
no rush.
know that they supported the next generation very large array, which I am happy about.
Yep.
And beyond that, and they want basically a new suite of great observatories. And I'm going to sneeze at some point.
Yeah. So they are pushing for Louvoir, Habex, Origins, and Lynx, in addition to the next generation. The next generation very large array. So
Yeah.
right now the very large array, I forget how many telescopes it is. It's like a dozen-ish telescopes in the New Mexico desert.
It's way more than that.
Well, they want 263.
Yeah,
for the
it's
new
more
version,
like the square kilometer array. It's
which will
currently
be across.
it's like
Yeah.
tens of scopes, and they're going to do an order of magnitude bigger.
And it'll be across the entire of North America. So there'll be some in Canada, some in Mexico, most in the Southwest United States, and that'll be amazing.
And this is a concept that basically combines the VLBA, Very Long Baseline Array Network, that has like a scope in Massachusetts, a scope in Puerto Rico, they just like stations all the way over the place. And there's one out near the VLA, and they will often tie in the VLA because it has a greater surface area, allowing them to get fainter objects, but the larger baseline allows them to get greater resolution. Now, by adding more systems to that, they can get higher resolution in more axes, and they can increase their surface area, which gets them fainter. It's just good in all different directions.
Oh yeah, it'll be amazing. It feels like we're gonna be getting a set of telescopes, instruments to answer these big questions that have all been. But I guess that's the natural way of things. That you generate a whole bunch of new questions, and then the next generation of telescopes come along to help answer those questions, and in doing so will generate a whole bunch of new questions, which then the next generation will come after that.
And we basically take turns with the wavelengths. So now that the Atacama Large Millimeter Array is there, we can go back to improving the longer wavelengths of radio. It's just back and forth, iterative improvement across everything we do.
And then the other thing, have you heard the news about the three body problem? Netflix has announced all the casting for the three body problem. Yeah, so they're going to probably do. I think it's going to be like 3 seasons to cover the 3 books, and they're going to start pretty soon to start filming, like doing production, and we should see, I think, the first one in 23, late 22, 23, and they're spending a lot, like hundreds of millions of dollars to produce this, so it's going to be pretty great. I'm really looking forward to it.
That is amazing. I'm trying to figure out if I need to get rid of a dog or not. She just came in. She's now destroying a large stuffed toy.
Yeah.
Okay, she ran back away. We're good.
Okay, just wanted you to see the kill.
Yeah, exactly. Yeah. Here, Mom, take this giant dead stuffed toy.
You still haven't read these yet, right? The three body problem?
I read the first one, and then I remember, I think it was you telling me that the second one had some issues and maybe not.
No,
it
the
wasn't
second
you.
one. No, the first one's kind of boring.
Yeah.
The second one is mind-bending.
Okay.
Really great, really exciting, intense, and kind of terrifying. And then the third one is the one that's deeply mind-bending.
Okay, so I will go back and read those.
Yeah.
I misremembered someone telling me it was problematic. Mind-bending, I'm down with.
There is a part that's like just a little bit problematic, but it could even just be a translation issue.
Okay.
Yeah, so you'll run across it and you'll go, when you read it.
Right.
Yeah, but you'll get it.
Okay.
But cultural, it's Chinese done, and then it's been translated, so
yeah,
I wouldn't be surprised. I like if I was translating it, I could translate it in a different way that would make the problem go away. So, but who knows if that was the intention in the original book. But anyway, I don't want
Right.
to sort of spoil it all. But we should do an episode.
We should. We should.
Yes.
And now is when we press record.
Okay. I've pressed record.
I have checked if my hair is on my microphone.
Yeah, because now it's Beth's job to press record.
Excellent.
Okay, let me find my intro. Here we go. Astronomy Cast, episode 619, Icy Moons and Dwarf Planets. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. How are you doing?
Doing great. We mentioned this in the pre-show, but the new Decadal Survey, the 2020 Decadal Survey, is out. You can freely download it and read all of the cool new science missions that are being suggested and backed by the National Academy of Science. It's a pretty exciting time to see what the future holds for space and astronomy and various missions and so on.
It's going to be a lot to go through. I know that they are looking for a next set of great observatories, and I am looking forward to seeing what we as a community are able to come up with and implement. And I just hope that this brings that next new level of innovation.
So cool. All right, so the outer solar system is far enough from the sun that water doesn't get blasted away into deep space. In this icy realm, there are many worlds with vast quantities of water ice. Today, let's look at the icy outer moons and dwarf planets. And we'll do that, but first a break. And we're back. All right, let's talk about the outer solar system, the icy objects. I'm trying to think. Are they the same? Are they different? What would be like your standard? What's your baseline here for an icy world, be it a moon or a dwarf planet out there in the Kuiper Belt?
Baseline. So I think that you basically have the parameter space of things that are the density of water to things that are the density of rock. And based on which it's closer to, you call it either an icy object or a rocky object. So here we're looking at things like Enceladus, Europa, when we're looking at icy moons, Triton. And
is that sound coming from you, Pamela?
Yeah, I'm sorry. I have two dogs that came in and are way more playful than they should be.
They're fighting.
Hi. Are you done now? All right, I think they're done. I'm going to answer that question over. I'm sorry for the editing that I'm requiring. Looking out at our outer solar system, we have lots of objects that have subsurface oceans that have densities that are closer to the density of water than the density of like granite. And it's in looking at their densities that we start to see this continuum from rocky stuff to icy stuff. And often, because things are so far away, we're not really sure where things are on that spectrum, but we know from their thin atmospheres of methane, ethane, ammonia, things like that, that these aren't objects like our world. There's something more like Pluto, and well, Pluto is kind of our OG icy planet.
Right. So then if you took a bandsaw and sliced Pluto or one of these other objects in half, what would you see as you took the two hemispheres apart?
There'd be a rocky core. Around it, there would be either a continuous ocean or pockets of ocean, depending on how the world is structured and how it's given up its heat. And then above that, you have layers of ice that can be kilometers to tens of kilometers thick and have their own mountain ranges from where the icy plates have come together, where craters have formed, and a variety of other, well, cryogeologic features.
And as you mentioned, in some cases, even a thin atmosphere.
Yes. And it's because they're so cold and because they're so tiny that we have such thin little atmospheres.
So then let's sort of, as we're going to be talking about these objects in today's episode, can you what would you like to add to the bucket? From where are we going to start? Are we going to include in Enceladus and then, or Europa?
So,
where do you want to start?
Let's first start by looking at the where these suckers are, because it's easy to forget how big our sun's, what we call the Hill sphere, that region of space around the sun where we can still hold on to stuff. It's easy to forget the size of that Hill sphere. And it turns out that the Oort cloud can extend a good 3/4 of the way to the nearest star, which is a bit off-putting to think about.
Do you want to?
Yeah, I need to get rid of these dogs. Hold on. Stella has grabbed Malachi by the collar and is dragging him in circles. Hold on. Yeah, you're a troublemaker. And I just unplugged my microphone. All right, we're going to need to figure that out. Come on, out. Out. You, go out. Come on.
Yeah, it might have been she's using a different microphone for connecting onto the YouTube than from the one that's being used to record the show. Okay. So she disconnected all the microphones. Now she's dismantling her couch. Her chair. Yeah, maybe. So she can't hear. Oh, that's right. And the audience can't hear Beth. So when I'm talking to myself, I'm talking to Beth.
Me, I am super hard on cables. Also me. I got something that's wireless. Still me. I then connected a wire to it and
Yeah.
yeah.
Yeah, you need no wires. You need those little iPod earphone things and a true wireless microphone that has no wires.
I could use this as a true wireless microphone, and that may end up happening.
Okay. So do you want to take another crack? You were talking about you want to think about
The Hill sphere,
where the Hill sphere and where these things are.
Okay. I think the real place to start is looking at just how expansive our solar system is. This is where we talk scientifically about the Hill sphere, this region of space where something is going to find itself bound to our sun instead of bound to some other object. And our Oort cloud can go out as far as 200,000 astronomical units. And that gets
2 light years.
Yeah.
Far. Yeah.
Yeah. And that gets it a good portion of the way to the next nearest star. So when you start looking at this massively expansive area, you find that there's that spherical Oort cloud where things have been flung. There is a disky portion of the Oort cloud that's lined up with the rest of the solar system. Then there's this area called the scattered disk, which is where we think a lot of the comets come from. And these are objects that have been flung outward by the planets and are a complement to the centaurs, which have been flung inward by the planets. So we have these things that are getting flung out, things that are getting flung in, this elliptical portion. And then, of course, there's the Kuiper Belt region, which is closer in to Neptune. And when you start looking at all these different sections, they don't have a whole lot of mass that we've discovered so far, although there could be some giant planets, as we've talked about, hiding out there. But it's a massive volume that these regions are taking up.
So, and yeah, I mean, when you think about like just the scale of the inner solar system compared to that, it's a fraction. Yeah. Most of the solar system is what you just described. Like times orders of magnitude. It's so big. And some of these objects have been captured by planets. Some are still orbiting roughly in the Kuiper Belt, and as you said, others have been kicked into really weird orbits.
And some of them just formed around the planets. And this is where you see that science works the same in a whole lot of different environments. So it looks like most of the moons, not all, but most of the moons that are of a size around Jupiter and Saturn, they formed there. But then when we go and look at Triton, it's orbiting backwards, is bigger than Pluto, and appears to be a captured Kuiper Belt object.
Yeah, like it's hard to understand how it might have formed in place in the wrong direction.
Right. And the meltiness of its surface seems to indicate that it had to dump energy at some point, and that led to the meltiness. And you can explain that from an object getting captured into an orbit that was highly elliptical. And the constant changing of the tidal forces as it went in closer and then zoomed back out would lead to it dumping the energy into these thermal effects. The orbit would circularize, and Triton would refreeze into the solid object we see today.
So you mentioned Triton. I'd like to just do a tour of some of these objects, which you have been cramming into your brain. So I'm going to let you decide what you'd like to talk about.
Well, so we're fairly familiar with the moons that count as icy objects. So there's Triton, Protus out at Neptune, going out to Uranus. We have all of the Shakespearean moons, so Miranda, Ariel, Umbriel, Titania, and Oberon. We don't know a lot about them because we basically have data from the Voyager missions. We'd like to have more data. We don't. So I can tell you that they're icy, they're cold, and they orbit Uranus. And that's about all I can tell you.
Right. They exist.
They exist. They
Right.
exist. But then coming in to Saturn, where we had Cassini for so long, this is where we start to understand some of the really cool physics that's involved when we look at Enceladus. Enceladus is an icy world that is experiencing tidal forces from Saturn. And part of the effect this has had is pressure built up inside. And it had to break through somewhere. And when it broke through in the slightly weaker areas near one of the poles, forming the first stripe. And it turns out that the pressurized water that came out through its surface would then go up, and then as the world rotated beneath, it would build up on the surface where it built up over time, and there's pressure still on the inside, leading to the next stripe. And this happened to get us to this whole series of parallel tiger stripes on Enceladus, and it's really amazing to look at.
That's interesting. I didn't realize that the stripes were formed in series as the moon's orientation changed to Saturn and sort of open. I'm sort of imagining like Hawaii's the hotspot that forms the Hawaiian Islands moving. Sort of a similar situation.
This is more like if you constantly are throwing snowballs onto weak ice and you can only throw them for 30 feet, you're going to end up with a buildup of snowballs 30 feet away that are eventually going to crack that ice. Here, that 30 feet has to do with material came out through the crack, the world is rotating beneath, the material builds up on that weak surface until it cracks at that new place. Now you have two cracks that are geysering up material. Planet rotates under the material, it builds up, it gets another crack, and it was only once it hit 4 cracks that enough pressure was released that it's not creating additional cracks.
Oh, okay, so it has stopped.
Yeah.
All right.
Yeah.
Well, we're gonna move on in your tour of interesting icy objects in a second, but it's time for a break. And we're back. All right. So, what else has been fascinating you in this region? Like I said, you're in charge here. I'm just gonna let you you call the shots.
All right. So from Saturn, let's cruise on over to Jupiter, where the Galilean moons were the first ones that really caught our attention as being worlds like no other. Here we're looking at Io, which is not an icy moon. It's a Galilean moon. I'm going to just lay it out right there. Today is not about Io. It's more about Europa, another one of these classic worlds that we see cryovolcanism, we see geysers. It's about Ganymede that appears to be a cratered icy shell and may also have an ocean underneath, but we don't know as much about it. It's about Callisto, which again, we just don't know as much about, but we see that cratering. And looking at these different worlds, we see through all their variations in colors, all their variations in structures, hints of what we might see if we're someday able to get out to these significantly further away dwarf planets that folks like Mike Brown have been turning up, not at a happy 5 AU like Jupiter, rounding a lot, but more like 40 AU, 90
Right.
AU away,
Yeah.
which makes observing a lot more difficult.
Yeah, I mean, Galileo was able to see the Galilean moons in his first very bad telescope.
Yes.
And yet, as you say, Mike Brown, with some of the biggest telescopes in the world, can just barely detect similar objects that just happen to be 20 times farther away.
And part of what we're dealing with is the difficulty in catching things moving. If you decide to take your Galileo look-alike scope, probably made of plastic, and go outside and look up at Jupiter over the course of the night, you can see its biggest moon zipping back and forth as they go round and round, and they appear to go back and forth because of their motion in front and behind Jupiter. Now, that's a single night you can see this happening. As you look at things that are further and further away, it gets harder and harder to see their change in position over a single night. With Pluto, you can just barely do it with a reasonable sized telescope. Now, with these more distant objects, one of the reasons that there's this massive resurgence in discovery of objects in the early 2000s is because prior to that, they'd been looking for things that were moving at basically 2 arc seconds a night-ish. And then they found Sedna, which was going at 1.75. And it was realized, oh no, we need to start looking for things that are moving slower and slower. And within 1 week, we saw, due to some nasty politics, the discovery announcements of Haumea, of Eris, of all these little tiny objects. And part of the reason for this was Mike Brown and his team had been sitting on the discovery of a lot of these objects while they got additional data, firmed up the orbital parameters, firmed up discoveries of moons, and they had submitted an abstract to a conference where they were planning to announce an object they had at that point codenamed Santa because it was discovered in December. And this is one of the fabulous things about how Mike comes up with names for his objects.
Yeah.
So he had a code named Santa. He had another one that was codenamed the Easter Bunny because it was found around Easter. And it will never be known exactly what happened. But a Spanish team looked through all of his observing logs, accessed the abstract, and within a couple of weeks of doing both of those things, announced Haimea's discovery. They had their own data.
Right. But it's entirely possible that they, by watching the activity of the finest planet hunter, finest on Earth,
yeah,
they got a hint of what he might have discovered.
Yeah, and part of the reason that it's so challenging is they'd had the data that they claimed was the discovery data for quite some time and hadn't found anything. And it was right after the abstract went in, and the abstract was public, and the log files Mike found out were public. He didn't realize all of these things were public, that suddenly these things are getting announced. And when Haimea was announced by the Spanish team, he didn't immediately know that this was based on all of these attempts to look at his log files and everything else, but he very quickly went public with everything he had, submitting discoveries of moons, submitting Eris. And when it was found out that it was the Spanish team that had accessed his logs, this led to basically filing of official academic grievances that, and all of this really overshadowed just how unamazingly cool there's a bunch of these objects that have names you say twice. Haimea is not one of them.
You don't say Haimea. All right.
So Haimea, one of the reasons he was sitting on it is in discovering it, they had discovered it has coloration that makes it appear really rocky. It has moons that are super icy. And there's an icy debris field nearby. And so the thinking goes that this may be an object that went through one heck of a nasty collision, got spun up so that it assumed this flattened shape that it has. And the moons are essentially knocked off chunks that used to be part of the object. It's just a super cool object that looks like it had, like so many things in our solar system, a super violent past. And he was doing all of this research and wanted to tell this full story all at once, and then got beat to the discovery announcement, which just hurts the soul because at the time this was the 10th planet. Now it was shortly after this, like 24 hours after this, that he's like, all right, drops down the observations and says, I have an object more massive than Pluto. And
all right,
again,
well, you know what? Wait. That's a perfect moment to go for another break. And then we'll find out what was that object.
All right.
And we're back. What was that object?
All right. So there is an object codenamed Xena with a moon that is codenamed Gabrielle. And it is of arguable radius, but it is thought from our best data now to be smaller in radius than Pluto, bigger than Pluto in mass. This means it's a denser object, a rockier object than Pluto. NASA originally called this object, which at the time of the announcement was not named officially, NASA called it the 10th planet in the solar system.
Mm-hmm.
And with the discovery of Haumea, which was big, with
Mea,
the
mea.
I'm determined to screw that one
Yeah,
up.
you are. It's funny.
With the discovery of Haumea, with the discovery of this object that would go on to be called Iris, with this discovery of an object that would be called Iris, it set the IAU into an interesting squabble where you had the naming committee for naming Kuiper Belt objects being like, we shall name things after creator deities, because that's the rule. So for instance, when you look at Gong Gong and Maki Maki, and these are names that are supposed to be duplicated, and this is why I screw up Haumea. When
Yeah.
you look at these objects, they have names that are the creator deities of various peoples around the world. And Mike has worked to get the Hawaiian island deities, to get the native peoples, the indigenous peoples of California's deities, to reach out to all of these places that the astronomy has touched and use the names that are important to those peoples. But if an object is a planet instead of a Kuiper Belt object, you aren't restricted to being a creator deity in how you name
Right.
it.
Clever.
So, is it a dwarf planet? That term didn't exist at the time. There were planets, there were Kuiper Belt objects. And so the question was, which committee was in charge of the name? And from an arguing over which committee gets responsibilities, things trickled through to, let's just define planet once and for all, unfortunately,
Right.
because the definition they came up with hopefully is not the definition for once and for all. But it's that definition and the discovery of first Haumea and then of Iris that has led to Mike Brown being forever known as the Pluto killer.
Right. And so, and obviously that was our first episode. We revisited this idea a few weeks back, that this was the chain of events that led to Pluto's loss of planethood. At this point, though, like, how many of these things are there out there? If you include all of the moons that qualify, if you include all of the dwarf planets, all of the large objects in the Kuiper Belt, anything that's reached hydrostatic equilibrium, how many objects are we looking at out there in the solar system?
We're looking at tens. I don't know the exact number at the moment, but the thing to remember is there are 2 moons bigger than Mercury.
Mm-hmm.
And so we are going essentially from things the size of the asteroid Vesta, kind of is like, well, not quite a circle, so we're going to go a snert bigger than Vesta and work our way all the way up through to Ganymede, which is bigger than Mercury. We're going to go past the size of Mercury, and hopefully find things in the future with the sought for planet 10 that is hopefully out there that we're waiting for LSST for.
Right.
So tens of objects. This is part of why the IAU was like, we don't want to have that many planets. No. It's a lame reason, but that was part of the reason.
Yeah, well, it's funny. Like this whole issue has caused, obviously, like such a PR crisis.
Yeah.
Everyone is really mad that Pluto is not considered a planet anymore. But even like we've taken to just calling these things worlds.
Yeah.
Like I no longer distinguish between planet, moon. I mean, I do, but in my mind, they're all worlds. That it's like this time, like if none of the old words are going to work, let's just use another word.
Yeah.
And there was an interesting proposal. We actually have an article on Universe Today about this, that various people are coming together and saying, like, let's just lose the concept of moon versus planet versus dwarf planet. Like there's
as a
so many of them.
Geological meaning. I think it's
Exactly. Yeah.
useful for dynamics. Like the
This orbits
fact,
that.
yeah, the fact that Eris has its moon uh, dys, dysnomia. The fact that we have moons around Haumea and Makemake, and Pluto has so many, and Gong has the one. Uh, Orcus, Cilicia, Quawars, Waywat. I just love the name Waywat.
Quawar, Waywat. Yeah.
Yeah, it's all these objects that are order of 500 to 1500 kilometers across. All these objects that have moons, the moon simply means they're big enough to hold on to something. And so dynamically that
Yeah.
word has meaning. And it's cool to think that things so much smaller than the Earth's moon have their own moons, and then asteroids have moons. Moon is a dynamical nomenclature.
Right.
I'm
And
down
so,
with
and so
keeping moon.
in this paper,
Yeah,
they propose that anything above 500 kilometers qualifies as a planet, as a world, whatever. Like it's
yeah,
reached hydrostatic equilibrium, capable of having, moons go around it. Um, and that by that measurement, if you count 500 kilometers and above, there are more than 100 in the solar system. So someone's going to have to come up with a brand new version of my very excellent mother just served me,
no.
and then move on with a whole other paragraph to
That's a
get
novel
through.
there. Not
Oh,
literally a novel, but
yeah.
now in that number, they're counting all of the asteroids and rocky things that side as well, aren't they?
Yeah, yeah.
Yeah,
Ceres, as you said, Vesta's a little too small. The moon, Io, Ganymede,
yeah,
etc.
yeah. It's getting to the point that while there are tens of icy objects that are known, named, and defined, once you start including all of the rocks, once you start looking at the theoretical models for all the things that we haven't discovered yet that are predicted to be out there based on the amount of the sky that we have accurately observed and the parts of the sky that are just too messy to accurately observe yet, there's going to be a whole lot more found.
Yep. Yeah. Yeah. I mean, like here we are, less than a year till Vera Rubin comes online, and it could double the number of objects that are out there.
Yeah. And what gets me is we've now found enough of these outer solar system objects that appear to be scattered disk objects by and large, or Kuiper belt objects. We've gotten to the point that some of them are sufficiently boring that no one is particularly invested in making sure they have a name. It's like there's a whole lot of asteroids out there that no one has bothered to name because there's just a lot of asteroids. Well, I was going through the list of all of the largest of the icy objects a month or two back, and I was just like, what did 2002 MS4 do so wrong
To
that
not
no
get a
one
cool
has?
name.
Yeah, it has no name. It is unnamed. It
Yeah.
was discovered in 2002.
Yeah.
And so I actually like reached out on Twitter to Mike Brown, and his response was basically, yeah, it's too boring. It's just like, I love that we've found enough of these that some of them are interesting and some of them we admit are boring at this point.
That's awesome. All right. Well, I think we've reached the end of this week's show. What a wonderful solar system we happen to find ourselves in. Thank you, Pamela.
Thank you. It's my pleasure.
All right. Do you have some names for us this week?
I do. As always, we are brought to you by you. This is a team effort. We have Beth in the background producing us today. Nancy is always keeping us in order. We have Rich doing the audio editing, Allie doing the video editing. So many people out there modding. All of this takes your help. And I'm so glad that we're able to pay our staff who do the thankless job of making Fraser and I look and sound good. And those of you who are supporting us on Patreon are the ones we count on every month to allow us to pay them every other week. So this week I want to thank Moose and Deer, GeForce 184, Shearsome, Arthur Latz Hall, Smansky, Brent Krenop, Stephen Coffey, The Mysterious Mark, Gabriel Galfin, Dustin A. Andrew Stevenson, Sanyaya Panfilenko, Planetar, Rachel Fry, Joe Wilkinson, Sean Freeman with Blixa the Cat, Anthony Burgess, Elad Avron, Glenn McDavid, Dean, the Air Major, John Useth, Roland Warmerdam, Bart Flaherty, Claudia Mastriani, Tim Garish, Arctic Fox, Stephen Veit, and Burko Roland. Thank you all so much. And I looked at the numbers over the weekend, and roughly 1 in 50 to 60 people that are out there subscribing are actually part of our Patreon community. So if you're one of those 49 not donating, you get a whole lot more cool content if you're part of the Patreon community. So consider joining at even just $1 a month, and we'll send you a lot more stuff. Thank you.
Awesome. All right. Thanks, everyone.
The part of this job I hate but have to do because I really, really am passionate about paying my people. I'm very passionate about making sure that Beth gets paid, Rich gets paid, things like that.
Right.
Fraser's way over here in my world. So that's why I'm looking far over my shoulder.
Sorry, I'm just exporting.
That's all right.
619.
And as a reminder, Rich, if you're out there watching, we have two ads going in this week. I'm watching my mouse go all over the place. It was moving around just a moment ago. I assume that was you. Or I have ghosts moving my mouse. There, you're moving it again. You don't play Animal Crossing, do you?
Me, no.
No. There was a new download yesterday, and I haven't figured out if they've added in more spacey stuff yet.
They have some space stuff in Animal Crossing?
Oh my goodness, yes. They have a ton of
I'm
space
intrigued.
stuff.
What do you play it on, the Switch?
Yeah. I have, my Switch is in a console, and I have its joystick. I hook it up to my monitor. So, yes.
My gaming PC, my streaming PC, they're one and the same, is sort of, I've got one of those like camp chairs, you know, those like fabric camp chairs. That is my gaming chair, because I can fold it up when I'm moving around in the back of the trailer when I'm not. Anyway, it's not very comfortable to sit for very long periods of time, and so there's these games that come out that I've wanted to play, and I just can't bring myself to sit down and play them because it's just, you know, it's deeply uncomfortable. Like I can do an hour-long live stream, no problem, but to sit and game for a couple of hours, no, my back kind of hurts. I'm hunched over. I don't like it. So I've been switching to games that I can play on my laptop, on my MacBook. And so the one I've been playing a lot of is called Mindustry.
Yes.
And have you played this?
I haven't played it. No, I've looked at it. So tell me if it's worth.
So it's I mean, you can get it for free. You can get the game totally for free, or you can pay like $7 on Steam if you want that as well. And it is like, I guess it's like a light version of Factorio, where you've got all these resources sitting around on the landscape, and you build conveyor belts and factories and mining equipment, and then you add these materials together to form more complicated stuff. So you add you make silicon from coal and sand, and then the silicon can help you make things out of glass and things like that. and it's very complicated because you sort of have to sort of think about processes to kind of keep everything like it's all about
It's like
like
if SimCity and Minecraft were violently convolved and
right.
had a genetically engineered child.
Well, it's very much like dealing exactly even like dealing with the supply chain crisis that we're going through right now, where various things are difficult to get your hands
Yeah.
on because of one chip that can't come in. You know,
Yeah.
if your guns loaded with silicon projectiles are there to defend your base, but you can't get the coal to get into the factory to build the silicon to feed it to the guns,
Right.
then the guns don't work.
Right.
And so it's all about like supply chain dynamics, and it's a very fun game. Definitely tickles a part of it. And then it's just like a tower defense game, so you're defending yourself against wave after wave of things that are attempting to attack you, and so you've got to scale up your industry to defend yourself in time to be able to deal with the ever increasing sort of danger of the waves that have been thrown against you. It's yeah, it's really clever. I really enjoying it. So anyway, but it's the kind of game that I can play just sitting on the laptop. It's very lightweight and a lot of fun. So I've been playing quite a bit of that.
That is cool. I can't see you playing Animal Crossing, to be entirely honest.
Oh sure, I play Animal Crossing. Yeah,
Okay.
that'd be fun.
Okay.
Yeah, yeah.
The Switch, like I love playing my Switch in bed.
Mm.
It's the perfect. Let me see if I can pull it out of its dock. Yeah, there we go.
There's a
It's
Steam version. Like I
down.
refuse to buy a proprietary piece of hardware like a Switch,
Okay.
and then have to buy their $50 games. I won't do it.
That's
Um,
that's fair. I
yeah,
didn't
but
buy the Switch. I stole it from my husband.
oh,
So that made it
yeah.
much easier. He
The
got it to play a game and then was done. And
Breath of the Wild, probably.
yeah.
Yeah. Um, but I but there's Steam has its own version that's coming out
Oh,
like probably in the
really?
next couple of months, and it's essentially it's a PC built into a Switch shaped device that you can then load your entire Steam library into and then play any game. So I could play Witcher 3 or whatever on the this device. So I think I'm gonna buy one because it feels like the right form factor to just kick back and play some games as opposed to sitting and playing the very
Yeah.
serious business of sitting in front of your gaming PC. I like that.
Yeah.
I like that mode of just kicking back and playing with consoles, and and I haven't been able to replicate. Like I found still like when I had
Right.
the Xbox, a lot more comfortable to just sit with a controller and play. So yeah, but then I also kind of want to I want to get back into No Man's Sky and like put it on the big TV
Yeah.
and or even try like the virtual. So there you go. Steam Deck is what the thing's called. Yeah, I
Okay.
should probably just put in my order for a Steam Deck. I'm pretty stoked on that idea.
That okay. Now
Yeah.
now I have no property of my computer right now. I need somebody
You're just a
DM me.
passenger.
I
You're just a
am.
passenger in cyberspace.
Someone DM me that I need to look out for the Steam Deck as opposed to a Stream Deck, which I already have.
Steam Deck. There you go.
Thank you. Okay.
Okay. Well, you know what? We've reached
Excellent.
the end of our hour, although we had a late start, but still, I think it's time to move on. So this is the new for people who are wondering, like, why did we start late? This is actually the new start time for Astronomy
Yeah.
Cast. Maybe we weren't clear, but last week we kind of
We
stumbled our way
realized
into
it was
this.
a bad idea.
Yeah, yeah, because Pamela would finish Daily Space and go right into Astronomy Cast, and it was always sort of a nightmare to
Yeah.
detangle her from one environment and then get her into the Astronomy Cast environment. And so now, theoretically, she's got a 1 hour long buffer, and
It's
yet,
excellent.
but she can get some food,
Yeah.
rehydrate, and play with the dogs until they're sick of her, and then she can come and show up in the show. So from here on out, 1 p.m. is the new start time, or
Yeah.
4 p.m. Eastern, or I don't know
So it's
when it is
saying
the
the
European
Steam
time.
Deck could come out in December, I
Yeah,
had totally asked my husband for a bathrobe for my birthday. No. Steam Deck. He's not getting
yes,
off that cheap this year.
that's awesome. Yeah, and they're not that expensive. $500
Yeah.
for, which is kind of the same price as a Switch
Yeah.
ish. Yeah, yeah. Now that I'm talking myself into it. I almost ordered the new Pixel 6, but then it clogged on Google
Oh.
Store. It clogged and wouldn't let me order one. So you know what, Google, you don't get my sale. I'm gonna get a Steam Deck instead.
I am not upgrading my phone until it either, like, the battery stops lasting the entirety of a day,
Yeah.
or I start traveling enough that I'm using it as more than a notification center. But currently it exists as a notification center, and that's it.
Right. Well, yeah. Um, anyway, let's wrap things up. So thank you everyone for joining us. Thank you to everyone, all the moderators who were helping out in the chat. Thanks to Beth operating behind the scenes, all of the editors that bring the show together. We couldn't do all this without you. Thanks to Pamela, my brainy co-host, and we will see all of you next week. Thanks, everyone.
Bye-bye. And I just want to say, while Beth finds all the buttons, I am loving you guys using all of my Star Strider remotes of the dogs. It is adorable. It is adorable. Thank you, Twitch audience, for getting the murder dog emote out where she belongs.
She barked just now.
Yeah, they know. They know they done good.
That is
Okay.
awesome.